Hi, this video explains about the examples in Bayes theorem. Here, the Bayes theorem already we have seen in the previous video. Probability of the event A going to happen given the probability of B that is already happened equal to probability of B given A multiplied with probability of A divided by probability of B given A multiplied with probability of A plus probability of B given negation A, the event which is not happened already, multiplied with probability of negation A. So here A is assumed as person is affected with disease, then B is the event, the person is just getting the cough, okay, coughing, right? So here from that we are deriving giving the values. First we are giving the values in the problem statement itself. Probability of flu, that is event A. Probability of flu, that is event A here, which is given is 0.05, which the all value is given already. The probability of cough, getting the cough due to flu, okay, probability of cough given flu is giving the cough, due to flu only getting the cough. Probability of event B given A equal to 0.8. If it is 0.8, probability of getting cough not happen, not due to the flu, so 1 minus 0.8 equal to 0.2. So this is 1 minus 0.8 equal to 0.2. So now we can substitute these values into this formula and calculate the values of probability of getting the flu due to cough, okay, due to given cough, probability of flu given cough. So when you're substituting the values here, you will get 0.17 approximately, 0.17 approximately, right? Now here the probability rule is the probability of conjunction of two events A and B, probability of conjunction of two events A and B. So here we can say probability of A intersection B is probability of A given B multiplied with probability of B. This is called product rule. This is called product rule. The probability of B given B intersection A equal to probability of B given A conjectured, that is multiplied with probability of A. Sum rule is disjunction of two events. Disjunction of two events, that is probability of A union B. Probability of A union B. So probability of A plus probability of B minus probability of A intersection B. Right? So this is the union. Then Bayes theorem is providing you the posterior probability from maximum likelihood and prior probability divided by marginal probability. The total probability is calculated by using assume there is the n number of events denoted A1 to An, which are all mutually exclusive, which are all mutually exclusive. Then we can say summation of events 1 to n, summation of event 1 to n, the probability of ai equal to 1, the sum of all the events, probability of all those, sum of probability of all the events to be 1, right? Then probability of B will be calculated by using sum of I equal to 1 to n, probability B, the next event happened due to already happened event AI multiplied with probability of AI. So like that you have to calculate for probability of B given AN multiplied with probability of AN. So until all the elements. So total probability here, assume the E1, E2, etc. En are n mutually exclusive event and also exhaustive events, exclusive and exhaustive events, which are all associated with the random experiment. if A is any event which is occurring with E1 or E2 or En, right, then we can calculate the probability of A can be probability of E1 dot multiplied with probability of A given E1 plus probability of E2 multiplied with probability of A given E2, etc. Probability of En multiplied with probability of A given En. So for example, the first bag is having 4 red color balls and 3 black color balls. The second bag having 2 red color balls and 4 black color balls. One bag will be selected randomly at a time. From the selected bag, one ball is going to draw out. What is the probability of getting the ball drawn from the bag is red? So here first we have to check which bag going to be used for drawing the ball. Then from that bag we are going to get the ball that will be red. So here this can be calculated by using the total probability. So selecting the bag 1, we can say E1. Selecting the bag 2, we can say event 2. From that we are going to select a from the bag 1 or bag 2, whichever ball you are going to draw, that will be a red. So when you are applying the total probability, probability of A equal to probability of E1. Selecting the first bag, from the first bag we are going to select the red color ball, right, and plus probability of E2. Selecting the maybe selecting the second bag, from the second bag we are going to select the red color ball. So by using this we can apply the values. So when you are applying the values, you will get the answer. You will get the answer, right? So here next one is the reverse probability. In the reverse probability, again we are assuming E1, E2, En are mutually exclusive and exhaustive events associated with the random experiment. So here previously we have calculated probability of getting the red color ball from the back. Okay, so here A given E, A given E, so right. So now here you look at that probability of A given E. This is what we have calculated. Now we are going to use reverse probability, probability of E given A, probability of E given A. So for that we can say probability of E multiplied with probability of A given E. So I is a number of events, E1, E2, E3, etc. En. Okay, so here the example is given. The table is showing event Y. So this is the event Y, right, which is having the two types of outcomes. One is A, another one event is B, which are dependent on another event with various dependent on another event X. So this is the X event with various outcomes. X event is having different outcomes, X1, X2, X3, different outcomes. Case 1, suppose if we don't have any information of the event A, then we can get the value for A from the sample space probability of prior probability. So this is already given. Okay, this is already given. Data about the A is already given. So that's why it is called prior probability. Probability of Y equal to A. A is occurring how many times? 1, 2, 3, 4, 5. So out of 10, we are having 5 number of A's. 5 divided by 10, we are getting the 0.5. Case 2, suppose we want to calculate conditional probability. Here the X is another event, right? The Y is depending on the X is depending on the Y, right? Y is depending on the X. So X is X2. When the value is X2, right, when Y is A, right, when Y is A, what is the value of X2? Okay, once again I'm repeating here, already Y is there. Okay, already Y is there with value A. So when Y equal to A, how many times x2 is appearing in the x. Okay, this is the x, right? This is the x. So how many times x2 is appearing, right? 1 2 3 4. Okay, 1 2 3 4, right? So here we are having the x2 4 times when a, so a, this is b, it is not calculated. Then this is also b, which is not calculated. So 2 times, so 2 out of 5, so 2 out of 5, so a is occurring 5 times. In this 5 times of a, x2 is appearing 2 times. That is the thing, 2 divided by 5, 0.4. So this is about the prior probabilities. From the prior probabilities we can calculate the prior and posterior probabilities. So thanks for watching.